Blockchain, and I am very happy to introduce our resident expert, Tom Niermann, who is an entrepreneur in residence with ITEN. ITEN, for those who may not know, we like to say we're the catalyst for tech innovation. We're approaching our 10th year in the St. Louis community, nonprofit organization that helps entrepreneurs as well as our corporate innovations with innovation tech across industry sector. So that's my little commercial. All right. So Tom has been the founder and CTO of 3 different venture-backed software companies and is the former head of technology and program management of strategic partnerships at Google. He's been an active member in St. Louis Archangels as well and has expertise in product marketing, engineering, and fundraising strategies. So with that, I'm going to turn it over to Tom and let him begin. Thanks, Tom.
Hi. So I'm going to talk about the blockchain and why it will eventually be a big deal. What I'm not going to talk about is the price of Bitcoin. I am not going to give any financial advice.
16,400.
Okay, my one bit of financial advice: buy Bitcoin 5 years ago. Other than that, if I knew when to buy and sell Bitcoin, I wouldn't be an engineer. I'd be a trader. And so I'm not a trader, and so I own $10 of Bitcoin is what I own. I checked earlier today, apparently, from me messing around with it. This is really about underlying technology of blockchain and how that can really change the world in the future. So this is much more of a visionary. I've done this like 3 times now, I guess. And it was started off as give a TED talk for this company on blockchain. And so whenever I do these technologies of the future things, I've done a few of these over the years, over the decades, the room is usually split when a new technology is starting to get visibility. There's people in the room who think it always takes longer than expected. How many would fall into that camp versus it always happens faster than anyone expects? So how many people think these new things take longer? Yeah, about half. How many people think these things always go faster? Okay. My answer is both. Yeah. That it's almost, there's not a word, not a word in the English language. It's deja vu, but it's about to happen again. It's happened to me several times. It's about to happen again. I don't know what that word is, but it's like a reverse deja vu. And so these things always come about. There's a lot of buzz. This happened with the internet. Remember when everyone, internet's just a toy. Personal computers. There's no reason for anyone to have a computer in the home, classic quote. iPhones. I remember so at Google, I did the Maps and YouTube for iPhones, and when they were released. And we had partnerships at Vodafone, which covered all of Europe, and KDDI, which covered Japan. And we did Maps, and so we did the same thing we did with them. But Apple wanted optimizations. And yeah, we'll see. We did kind of half-assed job just to please them. And the first day it was released, we were watching the numbers for Maps. I remember seeing you guys on, and it doubled the traffic of all of Vodafone, of Europe, and Japan for Maps usage on the first day. And it kept going up. It didn't stop. And so it was really an oh shit moment. We threw a bunch of servers to get all the maps working everywhere, and YouTube videos got transcoded and stuff because we had a load of servers. And so we were able to do that. So we quickly moved out of our half-assed to good job of doing it very quickly. But you know, it was definitely an oh shit moment. And we had Google Phone at the moment, and before that I was seeing 1,000 pull-out keyboards. I don't know how many different modes of pull-out keyboards I was seeing. After that day, I did not see another form of pull-out keyboard. And before that day, everyone was very proud of how we made this keyboard pop out and do this and flip around. And after that day, never saw one ever again in my life. And so it was an inflection point. And those happened with the internet, those happened with PCs, and at some point, I think it'll happen with the blockchain. And so this is why, so I'll kind of paint the picture of what will likely be the trigger moments of that. So let me just go over some terms. So there's blockchain, there's Bitcoin, and there's Ethereum, and there's a whole bunch of others. But these are the big threes. So blockchain is underlying technology. Bitcoin is, you know, what everyone hears about. It was the originator. Bitcoin was built on blockchain, and Ethereum is a newer version of blockchain. And so there's underlying technology. So everyone here, I assume, uses the internet, right? And yeah, exactly. And most of you probably know what HTML is, and have seen the brackets and stuff. And some number know what HTTP is, more so than what a 404 error is. And then, you know, you go down. You know, how many people know TCP/IP protocols? I did those. Yeah, some people with gray hair have done that. And the hardware link layer. Yeah, you know, but not in the last few decades. But you don't need to know any of this stuff in order to use the internet. The same thing is true with the blockchain. And so, in the blockchain, you have all this underlying technology, and on top of that are things that you care about, which are things that are going to show up in your wallet or distributed apps. That's what humans will care about. Stuff below here is what engineers care about. So let me just define these terms. So Bitcoin, it started out trying to be a currency, but the transaction costs are too insane now. So it's really an asset. It's like gold. So it's a way for people to store value that is not tied to a government. So, and is portable. So you don't have to bury gold in the backyard anymore. In case Armageddon happens, you can have it in Bitcoin, and you know it'll be there somewhere, and you can get it out from anywhere in the world. And so Ethereum is really, well, it has the aspects of the currency or asset. The differentiator, it's a contracts machine. So it's really about running a contract. What is a contract? It's an agreement between one or more parties to do certain things under certain conditions. That's all a contract is. The code that's in the contract, an Ethereum contract, is exactly that. The only difference is it's not enforced with judges, people reading some strange dialect of English. It's done in code, deterministic results, same thing every time, everywhere. And then another variant of it is Hyperledger, which is kind of, it's open source, but kind of driven by IBM. It's a more protected version of a contract machine. So the West Coast cares about Ethereum because this is the libertarian, we don't need no damn governments or regulations anywhere. This is the East Coast. Well, we actually live in the real world, and we have to deal with SEC, and so we want like protected and privacy and follow these rules and only ensure that you know, you could do the know your customer, anti-money laundering stuff, and things like that that are easier to regulate and fit into the existing regulations. So this is much more protected. Think like AOL, when you set up AOL for your grandma. Okay, it's the internet, but it's nice and safe. And this is the Wild West. So what is the blockchain? So all these are built on the blockchain, and underlying it, forgetting about blocks and cryptography and keys and all that other crap. You don't need to know that. All you need to know is it's a giant trust machine. What it creates is trust. It ensures that there's only one source of truth, and you can ensure that everyone has the same source of reality. So while other systems rely on institutions to create trust, banks or whatever, this is trust built into the code. That allows people who don't know each other, don't trust each other, wouldn't do business with each other because you don't trust each other. The trust is in the engine, not in the person, not in the reputation, not in anything else. It's in the code. So the contract is enforced, and it's going to be enforced whether you like it or not. And you can always trust that it will execute the way it was programmed to execute, and you can get access to it. So at the end of the day, the blockchain is a giant trust engine run on computers all over the planet. And so who's using the blockchain today? So the newest one is the Australian Stock Exchange is in very heavy testing and ready to go live after the first year for stock trading on the Australian exchange. And the reason they're doing that is because while today when you do trades, through Schwab or whatever, through the exchanges, it can take 2 or 3 days to settle your trades and you don't get the cash. Once a trade happens, it happens and the value transfers. The stock goes to this person, the money goes to this person. And within minutes, you can then trade again and trade again and trade again. And so it streamlined things, and so you don't have to unravel conflicts, because there is no conflicts, because the contract says this is what happens, and if you do it, you place a trade, there's no, oops, I didn't mean to do that, it's done. There's no humans that can unravel it. So there's other ones, tracking food, the food chain for food contamination. There's a whole bunch of stuff on international trade settlement going on with the big banks, JPMC and so on. Tracking shipping containers and diamonds. So it's all very much in the early stage. All these things, what they have in common, it's a large network of players doing kind of a similar task, and they may not know who each other are. So it's doing business with people you don't know, and therefore don't trust. So get back to the underlying thing. Why is a blockchain such a big deal? So the blockchain is contracts, transactions, and their records. That's what it stores. Contracts, transactions, and their records are the core defining structure of commerce. Contracts, transactions, and their records define entities, businesses. They define, they are the cornerstone of our economic, our legal system, and even our political systems. They protect our assets, they chronicle events, they govern interactions between individuals, businesses, and nations. Contracts, transactions, and their records are the cornerstone of all commerce. And at the end of the day, that is what business runs on these three things. There's all kinds of things on top of that. And so Bitcoin is the internet of money, but blockchain is going to be the basis for the internet of commerce, of how contracts, transactions, and their records are stored and chronicled throughout history. So to see forward, let's look back. Let's look at the evolution of commerce. So we started out, this is a mammoth, you can't see. So we started out with a barter system. So this axis is complexity of commerce, how far you can, what the distance of commerce was. So caveman days, you could trade maybe with the next tribe over, right? So there's a reason why towns are 10 miles apart, is because that's how far people can at most go 5 miles to town. And they did business with people they knew. And if you tried to screw somebody over, it was enforced with violence that you carried out yourself. So that was the rule of the land, was people you know, you built up your reputation, and it was enforced with violence. Coins came in about 600 BC, and we matured to outsourcing violence to soldiers. So it was, again, enforced with violence, but we outsourced it. So now the soldiers would kill you instead of you having to kill the other person if they tried to screw you over. And so, but the coins added to the distance. Now, you could travel throughout the Roman Empire, and you knew that piece of silver, because it had the stamp on it, was going to weigh 1 ounce, or whatever denomination they used at that time. So it had the same standard weight, so you could, it made distance and of trade a little bit easier. So the next thing was fiat currency, which came about 1000 AD in China. So this was the first time that something had value because the government said it had value. So Chinese government said this piece of paper has value, therefore it does, and therefore you can trade with it. That was the first time that a government dictated the value as opposed to the underlying silver or whatever metal they were using, gold or whatever. Along the way, contracts started coming in. People started writing down what they were agreeing to so that they could, again, go across further distances. And there were judges, i.e. the kings or whatever, the court would decide if someone's cheating or not. And about 1700 is when the first fractional reserve banking systems started in Sweden, not Switzerland, Sweden. And again, to try to get around the rules, there would be police and stuff, put you in jail or ultimately maybe. And that's where we stand. So commerce has not really progressed from fractional reserve banking forward. Yeah, we have credit cards, we have optimization, we have, but basically these banks are keeping ledgers. The ledgers were on paper. Now they're electronic, but basically banks have to share ledgers in order to see what reality is. And so where's the trust coming from? We're trusting the institutions that when we deposit money, that the money is there. So we're trusting the banks, insurance companies, we're trusting corporations, we're trusting governments, we're trusting IMF internationally. And we're also trusting trusting institutions like eBay, Uber, and Airbnb. We're trusting to get in a car with a stranger because of their reputation on the internet. We're trusting to rent out our apartment because of the reputation on the internet. So we're starting other institutions of trust, which either of these things would be crazy. When I was, you're not getting into a car with a stranger, young man. Now, whatever. And so we have trust, but we have verify. So the Russian proverb, whatever, I can't pronounce it anymore. So we have banks and contracts kind of implement transactions. But then we have regulatory stuff, legislature, executive branch, which rules on the board, right? So swim lanes, guardrails, make sure people know what the rules are that they're playing under. But then if people try to get around the rules, we have FBI, FinCEN, SEC, and stuff to investigate. And then we have the Attorney General to enforce it. Then we have the police to catch you. Then we have a judge to decide whether you really did break the law. And then if you did, maybe you're fined or you go to jail. How slow is this? So when there's a lot of talk about, regulations are a burden. I look at this, having well-defined rules isn't really the problem. Having to go through all this crap if people try to get around the rules, that's a burden. So when you say regulations, it's like, is it regulations or is it the crap around the regulations that you have to deal with, whether you're a good actor or a bad actor? In both cases, you have to deal with this crap. But just like in sports, if you have well-defined rules and everyone followed it, that actually makes things more sane. So, and think about one thing. The world is becoming more autonomous. Computers are doing more and more stuff. I built an AI that does trading that violates an SEC rule. I didn't mean to do that. I didn't break a rule. This AI program figured out on its own that the way to make more money was to do something. You're going to put the computer in jail? Or you're going to do the reverse electric chair, pull the plug? Yes, capital punishment humor. You know, this does not work going forward as the world becomes more and more autonomous and speeds up. And if you think about it, so that we have this, the gears of commerce today are, we want things to be efficient, but we want to trust the results. So like credit cards, we're kind of choosing efficiency over trust. You know, people can, you know, steal your credit card, and so, but if we try to increase the trust, oops, wrong way. All of a sudden the efficiency goes down because we have to put more rules and regulations and visibility and oversight around things. But if we want efficiency to go up, with credit cards, the trust in the transaction starts to go down. So we have this trade-off. What the blockchain really does is puts another gear in the system, which both increases the efficiency and increases the trust. And that wouldn't be true because, or otherwise this graphic wouldn't work. So, and I spent 20 minutes doing that. So, and while the blockchains of today, you can say probably aren't more efficient because the electricity uses and programmatically, compute-wise, they're not efficient, but human-wise, they absolutely are. In terms of number of people judging whether these things are valid and so on, the human efficiency has gone way up, and the trust has gone way up. And so that is why ultimately the blockchain has to be there in order to set the rules, define the rules, and enforce the rules. Because if enforcement with institutions, you have this whole stack to get through. In cryptography, in blockchain, it's enforced by design. The guardrails force you to not get around the rules. So if you have a trading rule where you can't have some limit of something, and if you did something over this limit, you couldn't do that trade. You put that in the contract, and guess what? You could never do that trade. Versus here, oh, you just skirted the rules, you got past it. Okay, now did someone catch you? Now, now what do you do? Oh, now you negotiate something like that. 5 years later, people are tired of it and just want to get it over with. And so, settle for some token amount. And if you think about, as things become more and more autonomous, regulation by, enforcement by unable to get around it as opposed to punishment. We have to move from the punitive way of regulation to the can't get around it way of regulation. And that's what the blockchain does. By having contracts that you can't change, that are well-defined, everyone knows the rules, then that defines commerce. And if you know the rules and you know you can't get around it, you don't spend your time doing that, trying to get around the rules and pushing the edge. You spend your time building better products, getting it to people, da-da-da-da-da. And so ultimately it creates a lot of efficiency because you try to get rid of some of the BS that goes on in trying to get around rules. So what is the characteristics of the blockchain that creates this? This ultimately, we're certainly not there. One is there's a shared reality. There's one source of truth. There's no fake ledgers. There's one source of reality, and everyone has that source of reality. So if the account says you have whatever, $1,000, and someone else has $1,000, and you buy something for $500, this person now has $500, this person has $1,500. There's no disputes, because it just happened. You have one source of reality. Everyone knows, no matter what banks they go to, what bank it's a single source of truth on the planet. As opposed to each database is a single source of truth. This is a single source of truth for the planet. And a single source of the rules of the game. Whatever commerce system, however you're trading, however you're interacting, whether it's stock trading or Uber ride or whatever, there's one pricing mechanism for Uber, and you know what it is, and peak pricing is spelled out, so there's no surprises. The other thing is the contracts. If you look at the contracts today, think of contracts as not necessarily the 300-page behemoths that you get when you do closing documents or whatever, but contracts can be very simple. And they can be a collection of simple rules, simple actions. When this happens, if this happens, then this happens on the other side. The contract is in code, as opposed to in a dialect of English that then has to be interpreted. Everyone interprets it different, and then you have to have a third party decide what the reality is. Contracts, from a legal sense, are so much more deterministic and valid when they're done in deterministic code, whether it's Python, pick your favorite programming language that's deterministic. It makes, again, business easy because you know the answer. You can simulate what will happen in different conditions. You don't have to wait for lawyers to interpret it. So if you're going to law school, by the way, learn to code. And this allows things that are too small for contracts today to be in contracts. And so it changes the definition of contracts from these things that you spend excessive amounts of money for lawyers to write that no one ever reads, to something that is executed at every transaction. And lastly, this is keeping a record of all the contracts and transactions. So it has a reputation. And it's a reputation you can keep yourself and share if you want. Think of Equifax. But don't think of it as the crap that, it's Equifax that you own your reputation because you have your transaction record of paying your mortgage and doing this and whatever else and having this many credit cards and paying these credit cards and whatever. And if you wanted to get a mortgage, you can then share that with someone else, all without Equifax in the middle. You own it because it's your account, and you can choose to share it or not. And so it's a reputation that even though you own it and you share it, you can't change it. So you can't fake it. So it's a reputation that you can own, but you can't fake. There's nothing else like that. Everything else that you had control over, you can manipulate and change and fake to be better. This would be much more, this is your transaction history. So if you so choose to share it, you can. That allows a lot of other financial transactions, both for the individual as well as businesses. Because your DUNS reputation or S&P things, there's just a lot of crap in there that is not necessarily reality. And if you think about banking transactions today, what is a bank transaction? It's really dumb. It's a dollar amount A from account X to account Y on a certain date. That's what the bank has. That's a transaction. In business, what is it? It's a purchase order signed off by these people, an invoice signed off by this and approved this time with these corrections, and approved and then paid at this time, da 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 da. All that is a real transaction. The transfer of dollar amount, when I say A, from account X to Y, is only the end product. The transaction is really that whole rich transaction. That's what matters. And having a single source of truth of that transaction on both sides, again, changes the paradigm of business. So in terms of the blockchain, the value is in the network effect. There's no reason to use a blockchain on like an internal system. If you're doing an internal ERP that only your people in your company use, you don't use a blockchain. It would really suck. Even between trusted entities, a small group, it just doesn't make sense. Where it makes sense is in a large network of entities individuals, businesses, nations that may or may not trust each other, may not know who each other are necessarily. But that's where the blockchain matters, because even though you don't know the individual, you can trust the individual. And I touched on this a little bit, but the two mega trends happening right now are AI and blockchain in IT. There's plenty on the medical side. And there's all kinds of interesting talks on the singularity and will we become slaves to super intelligent AI and all that stuff, which is interesting that we're more serious what we'll talk about. But ultimately, whether it's AI, self-driven, or human-driven, in both cases, the regulatory and guardrails that we have on the system won't keep up. And that's where a cryptography, blockchain-ish type of solution really needs to be in place in order to keep the systems efficient, to avoid kind of market manipulations that can happen once you have machines that are vastly more intelligent than humans doing these things and figuring out ways around stuff. But directed by a human. I want to find a way around this rule to make more money. Throw an AI at it and get around it. You want regulations that are not subject to humans to find it, judges to understand it, and You want to put guardrails on the systems ahead of time so that commerce, business, and frankly our society stay within boundaries. And this can apply to a lot of different things. And so the blockchain is the one thing where it's mathematically very, very difficult to get around it. And so, and there's ways to make it impossible even for AI. And so that's why to me, is the balance going forward of as the rate of progress accelerates greatly, the guardrails. AI is playing offense, blockchain is playing defense. And so I'll do the 1-minute commercial on what Buildchain is doing. So what I'm doing with Buildchain is, in the construction industry, you have a lot of players on even a single project. You have developers, banks, general contractor, a bunch of subcontractors, sub-subcontractors, material suppliers, equipment providers. And they all have contracts, and they all want to get paid, and everyone above them that pays them wants to delay payment, and everyone on the bottom wants to get paid faster. And they all get around the rules, trying to stretch payments, and you didn't finish it. And so the idea is put it into a blockchain check system where the contracts are in the code so that if it says you get paid in 30 days, you'll get paid in 30 days because it's conditional cash that is flowing down from the originating developer down through the system. And there's still humans that approve that, yes, you did do the drywall, or you did do the roof, or you did do the carpeting, or whatever. But once it's done, and it's shown to be done, then payments are regular. And if you have regular payments, you can then easily finance those. So a third-party marketplace could get you money even faster than the 30 or 60 or 90 days that are in the contract, because if you have a reliable, high-integrity invoice, invoice marketplace, you can get payments on the spot when it's approved for basically a single percentage point discount. So for a point.
Factoring?
It's like factoring, but not at, factoring is kind of the payday loan of the business world. Factoring, you might pay 20 or 30% off the top to get money today. This would be invoice finance marketplace where you pay about 1% off the top. So it's vastly different because you're dealing with high integrity invoices with programmatic certainty that you will get paid.
1% versus 20%.
And 20% at the top, yeah. And so that's the difference. That's where it becomes more like a credit card transaction fee as opposed to a loan. So that's where I'd end, and questions.
Yeah, I mean, I guess in that particular case, how do you guarantee those things if they aren't funded?
I'm sorry?
I said, I'm just thinking about your particular, like, your particular application of Buildchain. How do you guarantee those things if they aren't funded?
So it's relative guarantee. So basically, the subcontractors are getting loans at a very low rate based on the credibility of the bank and developer. And so instead of two guys in a pickup's credibility, it's Wells Fargo Bank's credibility because they're funding this project. So you know, two guys in a pickup versus Wells Fargo, they get different rates. So that's where it comes in. Yeah.
2 points. One is you're talking about the contracts at the front end. You're assuming a very black and white world. It either is or is not. You have the regulations, and either this happened or it did not happen. There is no variation authorization. The other thing is you talk about building the contracts. If it's not in the contract, I see contracts being much larger because of all of the
conditions.
Yes.
What if this happens? What if this happens? What if this happens?
correct.
Yeah.
And so and how do you write all of that in and know what it is that you want to do and have to do because you haven't been in that position before?
So the same thing is true with English contracts.
True, but there's lots of authorization for interpretation, which
There-
you lose in the blockchain.
But it's the same thing in code, but the difference is when you're writing the code, you can do the testing, and especially with proof of completeness aspects, which these are smaller chunks of code, you can do what are all the different scenarios, and you will have a deterministic result. You may not have thought about the scenario, but you will have a deterministic result. So when I write a program, I can't know every way somebody's going to use it. But if someone uses it a way I hadn't thought of, if two people do the same thing I hadn't thought of, the same result will come out in the end. And so that is the interpretation. And so again, just like writing the legal English contract, the burden is on writing it and doing it complete at both cases.
Right.
And the difference is, as we see in the software world versus the legal world, the code sharing open source aspect of code is vastly better than the legal department. And so the reuse and rechecking of code to ensure completeness in all the use cases piles up much more rapidly in software than it does in legal contracts. Just because it's reused and shared so many times and people fix it along the way. And so the open source model has taken off much more on the code side than it has on the code side. But there is, there's always a learning curve, and there's always mistakes along the way, and you're absolutely right. I talked about the black and white world.
World is
The hard part is in that middle. That's where,
where the world is.
well, that's where the world is for the, I don't know how many years, but that's where the world is now and for some number of years. But as the code base of rules build up, then it becomes much more black and white, because that's what the code does. Yeah.
How big does the blockchain get in
So-
storage?
So if we're doing large contracts that I'm kind of envisioning, kind of alluded to here, the current technology will not keep up because it's replicated on every single mining machine around the world, and so it will not keep up. So there has to be other modes that scale to a much larger scale than what I have today. And there's some, Corda and some others are doing things along those lines, such that it will scale. But Ethereum and especially Bitcoin would not scale to what this is. There needs to be another generational blockchain aspect. Keep it cryptography. Yes.
Can you give me like the 30-second kind of, I don't know, the human interaction or how we're talking about third-party verification of delivery? So how, is that third party or is that, how, because that seems to be the biggest part, you know?
So there's so there's the code and then what's happening in the real world.
Correct.
And so what is the bridge between the real world and the
Well,
code?
yeah, the third, who's actually verifying the delivery or that this was done on time or that this was actually
It's
Up to standard.
Yeah, so it's, so in the Buildchain case, it's, a human has to say, yes, I approve it, it's done, the carpet was put in, the drywall was done. So there always is a human that says that.
Is that
But you know who
third
the human was, when they did it, where they did it, and you have a record of that human saying, yes, it's done.
So is that a third party, and if so, is that part of the contract?
It could be, you could also have a third-party inspector in the building case. Where a third-party inspector, and you have a marketplace of inspectors that go in and show that, oh yes, if there's a dispute, is the carpet in or not, you can have a third party do that as well. And then you have a record of that.
Right.
And so it depends on how you write the contract, how you want verification.
Right.
Yeah.
Could you see the dollar being on top of the blockchain?
Oh, yeah. So there's a dollar peg coin. I forgot what it's called, but there's too many coins.
USDC.
Yeah, it's interesting. And so, yeah, like Buildchain, the underlying currency, because no one wants floating. It would all be dollar pegged, or euro, or whatever. Yeah.
Usually, you mentioned Nestle, Purina, and there's Nestle, IBM, and Walmart, all collaborating on food safety data. What would that look like?
So what they're doing is, so Walmart put out, well, I think IBM does a lot of code. Walmart put out basically an open chain that people in this food supply chain can register. You know, you grow tomatoes. Okay, I just grew tomatoes, I registered it, I gave it to the trucking company, boom. And you register it on the blockchain. They don't even know if it's going to go to Walmart or not. Now the trucking company delivers it to the processing or whatever. They say it's there. The processing puts it into cans of tomato sauce. They say, I've done this with this batch of, this collection of tomato deliveries. So at any point, they're doing that because the tomatoes that have been registered and the end line processed product have more value because they know where they came from. Whether or not they end up going to Walmart or not, there's an incentive for everyone to just register it on the system, and so then it's an open system that the food can go anywhere, whether it goes to Schnucks or Walmart or wherever. And so it's still early, and they're doing it kind of one food at a time, but the concept makes a lot of sense, and so far they have gotten adoption of the food classification. Sorry, Jim.
Doesn't this eventually result in a lot of, for lack of a better term, ERP systems for this type of transaction, this package, this type of transaction? If you take your analogy of building a house, and who's going to check off on what, you could productize that with blockchain and have the criminal element of that program available through application.
Yeah, I think.
Is that where this heads?
Well, I think, and I've talked to some CTOs of some large banks that see banking going this direction as opposed to being dumb transactions,
Right.
that they are domain-specific, a set of domain-specific, so they add more value than just dollar transfers. So that certainly could be the mode going forward. Now, there's stuff on top of that transaction, so you have the internal view of all your transactions. So there's a lot, ERP does a lot of stuff, right? So it's more than just the transactions analysis and everything else. So I think aspects are what you're saying, but there's also, analysis and financial planning and stuff like that. More company specific.
What was this question used?
Oh, sorry. It was, how to say it? It was, does that mean the world kind of goes to more domain-specific ERP? And I kind of changed it. I'm not sure if it's ERP or domain-specific.
Just a set
banking.
of code that does this function.
Yeah. Yeah, and I think that's true. It's a code that does this function, whether or not it's called ERP, probably not. But it's a banking product for specific domains that do certain types of transactions. And so there'll be silos of these types of transactions, whether it's construction or trucking or whatever. Okay.
So last week, the improbable happened, and it was recorded that there was a breach in Bitcoin for $60 million. Do you know what happened there, and how can we still trust the system of blockchain whenever it's supposed to be unbreached?
So there are 3 ways to break the blockchain. Mathematically, there are 3 ways. One is for some entity to have over 50% of the mining power, which is, that's a shitload of money. It's just big denomination. And so the second is that you reverse someone's password. So every account on your check that you have today, when you write a check, it has your account number and your bank number on it, ABA. With those 2 numbers, you can send money or receive money. So if I have anyone's check here, I could forge a check and get money from it, and I might get caught, might not. With blockchain, there's no bank number because it's just a block built Bitcoin. And the account number is only send only. There's another password, and it's a huge number. It's not, password or birthday. And so all the breaches have breached humans. Humans give their password to companies. I don't want to keep this big number. What if I lose it? So I'm going to trust Coinbase or some other company to keep this big ass number, and I'll remember my name of my dog, first dog, as my password. And guess what? When those long passwords are kept in companies, employees have access to it.
So the breach was on Coinbase?
It wasn't Coinbase. It wasn't, but it was some. It was Coinbase. How they do it is pretty darn secure. It was somebody else. So it's what happens is humans give their password to another entity, and someone in that entity takes it. Now, with Bitcoin, you can just make your own account and keep that number, print it out on a piece of paper, put it in a safe deposit box, and no one will ever get it. Now, if you lose it, there's no getting it back. It's gone forever. And some amount of Bitcoin has been lost, a big amount of Bitcoin has been lost that way.
So there's rumors that, and I mean, you don't know if it's true or not, right? The amount of people that are mining, right, are decreasing. So that obviously has an impact. I mean, is there a concern that we all, like the whirlwind blockchain, that we won't have enough miners?
Well, I think there's Bitcoin today, and there'll be changes because with quantum computers, there will be ways to break passwords. Now, quantum computers will be able to break a password, but they're still pretty early, so roll forward 5 years. It's still cost prohibitive. You spend $1 billion to get a few $1,000. It just doesn't make sense right now, but that cost benefit will start to change. So there are other ways to make it even more secure. And so the blockchain has to go through some generations as technology progresses to prevent that from happening. So if things stayed the same with blockchain, there'd be all kinds of ways it would break.
So for mining?
And mining, it could get consolidated, because there's mining pools and so on it's, but right now, given it's also in the plan, you have different countries, it's hard to coordinate and to get a majority. And everyone knows if anyone has that ability, the value of Bitcoin drops significantly. So no one wants anyone to have a majority. Even people who are miners don't want to get a majority because then that makes the value go down.
I wasn't asking about security. I'm just saying the number. So obviously the mining organizations are the ones that are doing the calculations.
Yep.
Right? Continue to pass along the Bitcoin. But we have less miners because of it.
Well, I think the mining capacity is going up, especially as Bitcoin price is going up. So some got shut down when the Bitcoin price was down, and it wasn't worth the cost of the electricity to do mining. Now, as the cost has obviously gone up, no one's shutting them off because of electricity costs, and transaction costs are through the roof as well. So the miners are adding capacity today because of the price. If the price drops to $100, capacity will drop because it will be beyond the cost of electricity. So, but then as it's almost a supply-demand problem. So as the price goes down, mining capacity will go down with it, but otherwise they'll go bankrupt.
How large are the contracts you're working on, and is that a problem with when you roll out? Or
the contracts, so working on an Ethereum contract is like going back to assembly language program. It is, you can just do these tiniest of tiny things. And it's a lesson in, oh shit, I can't do that. Oh, I can't do that. I can't do that. Okay, let me simplify it. Oh, okay, got that. And so the contract ends up being, hashing of things that are stored and computed elsewhere. And so there's ways of doing it so that you don't spend too much on the actual chain, but you verify it off chain. So there's ways around the limitations of Ethereum, but there is absolutely next generation that's going to happen.
We get one more question.
One more question, okay.
What's a good layman's definition of what blockchain is?
Giant trust engine.
That's not a layman. It's
a giant ledger. It's a ledger that everyone trusts because everyone is a global ledger.
It's an open source software system that enables that, and then data is on there and distributed globally.
It's not just open source, it's an open entity. So it's running. It's not just I download the code and I have a ledger. It's one ledger for the planet. And everyone has the same source of truth of the ledger of Bitcoin ledger. And so it's a ledger everyone can trust.
Is there a language behind Ethereum or?
They have a Solidity, yeah. It's a
Ethereum uses Solidity.
Solidity.
It's something that they developed.
Yeah, frankly, you can use so little with anything that's any language.
everyone to trust?
Okay, we gotta wrap it up.